Welcome to today's webinar, Photogrammetry as a tool for the forensic documentation. Today will be with you, Marko from 3D survey team. Some of you already know me. We can officially start with the webinar. I must say the webinar is recording, so if you don't understand anything during the webinar, feel free to watch the webinar again. You will get the webinar link, webinar replay link after the webinar, not a problem. Another thing I would like to inform you is in the right lower corner of the webinar platform, you have a chat option. Please feel free to write your questions in the chat box, and I will answer them during the webinar or at the end of the webinar. We will see how it goes. So please, if you have some questions, we are running the webinar in live. You can get your answers immediately. Use this opportunity. Okay. I think now we are ready for presentation, and let's have a quick overview. What we are going to see today is, and we will talk about accident mapping. So when the road accident happens, the authority must close the roads for traffic, sometimes for hours. Therefore, scenes should be captured as fast as possible and as detailed as possible. Maybe you already know a bit more of this technology, but this is kind of pretty strong technology for really quick data acquisition to gather a lot of data and process later them in the office. In this free webinar, we will not only show you how we are doing it, but also how fast and accurate it's done. We will also explain the benefits of using this technology compared to traditional approach. First, we will see the problem and solution slide. So we all know that traditional approach is kind of too time consuming, and the road needs to be closed for several hours. Additional objects on the field needs to be measured accurately and properly, what's actually pretty hard in most cases. We will discuss about this problem. We will give you the solution, how we work today, how actually police department works today. They equip themselves with drones, with photogrammetry softwares. They step forward, and they're doing a really nice project, must say. Then in our second point, we will share with you field experience, how to plan a mission, what kind of mission type you use, what case and what technology is the most powerful and how to use it. And then third point will be the processing workflow, from images to 3D model, and of course output results from 3D survey. You will be able to see how we are working it, what can we export. If there are any questions, please do not hesitate to ask me. Okay, and then of course additionally questions and answers. There will be some time for answer your questions. The complete webinar should be around 45 minutes to 1 hour. And also after the webinar, feel free to contact us on our support email or info@3dsurvey.si. If there's anything unclear, we can reply, support you via email or phone call. What was actually the idea for this webinar is when Slovenian Police Department, General Police Department of Slovenia decided actually to invest into drones and 3D survey software. We did for them complete training, so it means we did a site training, how to map it. We did an office training, how to work with 3D survey to be as much effective as possible. Our case study was actually accident mapping site. We did an accident simulation, did a mapping with a Phantom 4 Pro, triggered images in 3 circle modes. We will see this later in the presentation, and based on this we try to put everything together as a best practice for mapping the accident size for example police department, for forensic documentation and similar purposes. From the field we get some additional experience, for example how to orientate the model. In case we don't have a GNSS device, we know the survey grade GNSS device costs 5,000 to 10,000 euros. And if every police department group needs to have it owns, it's quite expensive. If you have an option to eliminate this one, this offers department to have more drones, more softwares, and just to be faster on the field and do data acquisition more effective. At the end, we did a complete workflow training, and we can share the results today with you, how everything goes. Before I start with this presentation, with this organizing this webinar, I was in contact with the General Police Department. I asked them how they are satisfied, how they use the software in a daily basis, and I was pretty surprised how widely they use the software, not just for accident mapping, but actually the first point on the how they use the technology is actually fire documentation for bigger objects. They're using this on a daily basis actually. So after the fires burns down, they need to document it. They need to do the research. There is always dangerous to walk, so they observe with the drones first the fire site, then they do the 3D model documentation for inspection or some dangerous objects and so on. The same goes with fires in the nature, to monitor where the fire is going, how big is the fire site, and they can inspect really nicely everything around it. Then they're also inspecting a criminal activity. Looks like a lot of people, or some of them, are stealing also materials from open pit mines and everything like that. And it looks like not just surveyors are calculating volume calculations, also crime inspection is doing this, and they use the software on a daily basis for such a project. The another one, I was surprised, they do a garbage dance inspections, also because of fires maybe. Nevertheless, search and rescue actions are also pretty often situations where they need this technology. And I was really surprised for what kind of purposes are they currently already using this technology, and are pretty effective with it. When I asked them what kind of workflow are they currently using with the photogrammetry and 3D survey, they described me. First, they do a site inspection with the help of drone. Already a real-time video help them to inspect what's happening on the field. Then the second point is they do a 3D mapping with a 3D survey pilot. As you probably already know, we have also Android and iOS platform for mission planning for most DJI drones. We learn them how to use it, and they usually do a double grid mission plus 1 or 2 circles around the area of interest, because this definitely gives you the nicest 3D model and most accurate one, and after it you can extract any 2D 3D information you like. Then the third step is they do the processing 3D survey. They create a realistic full 3D models, create a true orthophoto, use the recorder function 3D survey to capture fly-throughs through the models. So we have a really nice integrated engine for video rendering. You will see at the end of the presentation. And then they give this further to further people who are working with this. And they're super satisfied with this one because they improve the traditional workflow pretty much. They speed up the time for data acquisition on a field. And when I asked them for benefits they delivered with this approach, the first one was definitely higher accuracy. So before they need to measure everything with a measuring tape on a field or similar equipment, they just do imagery with the drone, process then in 3D survey and get really accurate 3D data. Nothing is forgotten on a field, so everything what's on the image is saved also later in a 3D. The second benefits is faster data acquisition and a better documentation. So they speed up the complete process pretty much. If they need, for example, whole day for some fire inspection after the fire, no, they can do this in 2 hours or something like that. If they need to close the road, we know this costs additional money. People are nervous to wait when the road is closed. With this technology, they're just much faster and more efficient. Then third one, maybe the most important one, safety. Before you need to walk there, or you need or they use a firefighter's crane or similar objects to come and see what's on the field. Now they can easily do really quickly and safely. Then with this technology, as a result, you get a nice 3D model. Even if you have a smaller area, which one you inspect, at the end you get a brighter scene and you have much better spatial awareness. I've been discussing about the laser scanner, which they used in past. They are still using it, but the benefit of photogrammetry is exactly this one. You get the brighter area. You get immediately colored point clouds, you get textured, realistic 3D models, so the spatial awareness is much better. Then they have no possibility for later accident reconstruction because all the objects are metrically set in the accident scene. They can do the accident reconstruction almost with no limitation. And this offers them better and more detailed documentation. When I asked them how they used before they used 3D surveying technology, they just described me. We used most of the things we observed from the field. What we can see is that's it. If there was something high or anything like that, they tried to contact firefighters for cranes. They helped them and together inspect and see what was actually happened on a field. And of course, sketch and pencil, these were the only thing they could use it to document the site. Of course, they did some additional images, but they didn't process them in a 3D processing software. They made a kind of sketch on paper, note everything with pencil, try to measure it, but we all know how difficult this is. So if you would like to do this accurately and detailedly enough, you can spend hours and hours doing this. So right now, they did a really nice step forward with this technology, are more efficient, faster, and more accurate. Now, they're trying to push this technology also for accident mapping. So to use the same technology also in real cases for every accident when it happens, that they do the documentation of a site. And that was the reason why we did the training with them. The idea for this webinar comes also from this part. And definitely what we did, we first did site training for them. We simulate the accident, as you can see it on our left image. This is actually a point cloud from our training site, 2 cars which collision against. And we start the training with our 3D survey pilot. It's a kind of free app which you can download it from Google Store, Google Play, or Android or iOS Store. And what we figure out, we actually figure out that the most effective way for kind of dot accidents, so for small accident site, would be to do a 3-circle flights with the different camera angles on different height, and the circle should have different radius. And I actually prepared a video for you. Just a second to roll on this video, that you can have a feeling how to plan the mission to capture the best images for best 3D models. So here is our video. Here we can already see our 3D survey pilot app. We have different missions available here. As we already discussed, for this case, for accident mapping, we will use circle mode. That's why I will select circle. I'm right now in the office, but let me just zoom to my exact position where we did the training for site accident inspection, and it's right here. What we figure out there is it's actually really hard to get a center of your accident based on the background maps, because the background maps are not accurate enough. That's why we advise you to do to start your drone, fly over the accident on a 10-meter height or something like that, turn the camera gimbal fully down to see your accident in a center of your camera, and this will help you to position the circle exactly over your area of interest, over the accident. Once you have the center position, with the help of drone, you can smaller the circle, move it again over the drone icon, which will be visible there. This will take you probably a minute or two of your flight, but nevertheless you have 20-25 minutes of battery, so not a problem, and at the end you will get really accurate and nice results. Okay, after we center our circle, we click on the settings button and we will set the first circle, the highest one, on a 20-meter height. What we have in addition here, angle between images 10. This is more than enough. It will trigger 36 images per circle, max speed 5 meters per second, camera angle 47 degrees. This camera angle is automatically recalculated based on the radius of your circle and the flying height. The highest circle on 20 meters will have the smaller radius because we like to have more nadir images in this case, to get the terrain out from the model and so on. And when we are ready to go, click the setting button again to close the setting, play button to start your flight. Of course, I'm not connected with the drone now. Let's simulate the drone is now flying. It will take us probably 1 minute. During the flight, we see the camera angle, we see the camera perspective, what we see. What's nice to know, you can always change and improve the camera angle of your gimbal with the remote controller during the flight. You can even rotate the drone a bit more to the center position if the automatical settings were not set perfectly. So don't be afraid, you can try this out, works really nice. And then what's next important to know, after the circle mission is finished, just click on stop. Don't need to land the drone can hover in the air, and you just click on the settings button and you go 5 meters lower. Flying height AGL on 15 meters. This will be our second circle. Click on the settings button, on edit mode button, and increase the radius for your second circle. Place them again. The center of the circle should be over the accident site, and once again play button and wait to capture another 36 images from a bit different perspective, from lower flying height. After you finish this second circles, don't land the drone. Again, click on settings button, go 5 meter lower on a 10 meters AGL height, increase the circle radius a bit more to have even more side images. In this case, you will have uh, really nicely gathered data for all perspectives to get the most accurate and best 3D models later when we're processing the data in 3D survey. And then click on play, wait another minute or two, improve the gimbal position if you need with the remote controller, rotate the drone a bit with the remote controller stick if you need, and let's say after 10 minutes you're more or less finished with data acquisition on the field for accurate 3D model generation. Why I start with the highest circle is just because of safety. On the 20 meters, probably there are no trees, no traffic lights on similar objects. You get a good idea where the drone will fly, even later on the second and third circle, which will be lower and the radius will be bigger. Then you can also, if there are some trees or anything like that, you can stop the drone, do the manual flight in addition to get additional data and so on. So we advise you to start with the higher circle on 20 meters, then go on a 50 meters, and then even lower 10 meters. And this is the best approach to get an accurate 3D model. So this is everything about the planning in a 3D survey pilot app. Let's go now in the office and see the results from the field. Okay, this was a quick introduction how to plan your mission on a field. Hopefully you heard a few tips and tricks via the videos. So not sure if you know, you can plan your mission during the flight, so you don't need to land it. You just send the data up to the drone with the help of 3D Survey Pilot application and continue the flight. This just gives you the higher efficiency, speed up to gathering all the data and so on. And what I would like to repeat here again is sometimes it's really hard to center the circle, the center of the circle over the accident area, and in this case maybe the camera will not point in the center of your model, but nevertheless you can leave the drone flying in the circle mode and you correct the position of the camera. So you have a gimbal setting with the roller, you can put the gimbal up or down to really focus your area of interest in the accident site. And in addition, if you use the drone remote switch sticks, you can rotate the drone a bit. So you're not going to be able to move the drone from the circle mode. The drone will fly always in the circle, but you will be able to rotate the drone a bit more. So if you didn't if you didn't plan accurately enough, you can correct this during the flight. Okay, cool. This was our 3D survey pilot. We did the data acquisition on the field with them, and we came back to the office. And let's see what we get. Okay, here is already image. I think we are ready for my second video where I will roll on workflow in 3D survey. Okay, to speed up the complete processing step, I did a short video also from the 3D survey, how to import the images, how to orientate the model. Here is a bit different scenarios. We have kind of simulation on GNSS device, okay, and everything you will be able to see in this video. Once again, I would just like to remember you, if there are questions, please feel free to write them in a chat box, okay, and I can answer them during the webinar. Okay, let's continue now with my second video presentation, and this will be now the workflow. And here we can already see our 3D survey screen. We start with a new project. I will just select all the images we triggered with 3 circles and open them. In telemetry pop-up window, we select Phantom 4 or Phantom 4 Pro, Phantom 4 RTK. All those drones support EXIF data import. EXIF data is telemetry information which are written in each image. Most of drones support this type, and just let's select EXIF data. Coordinate system, I can select Slovenia one. If not, I can also leave it to automatic mode, and that's it. Vertical coordinate system, it's more for surveying purposes. Let's leave the standard one and import the images. Successful imported. When I click OK, I get all additional data about the images. So the geographical coordinates, the mathematical coordinates, accuracy of the images where they were triggered. Because this was a standard Phantom 4 Pro drone, not an RTK, the accuracy a bit lower, but the end model will be pretty accurate with the help of orientation. Okay, I will close down this pop-up, and if I zoom out, this is exactly the same area where we also plan our mission before, as we already see it. Actually, it was a bit lower here. If I check here to standard view, I can zoom in addition, and you will see those three circles, how the drone nicely fly, triggered images, and if I click on image tab, I can see also my images which are already imported in 3D Survey. I didn't mention before about the orientation. Now here is a nice image where you can see three 3D survey targets which were placed perpendicular to each other, and the distance between them was 3 meters. In this way we generate so-called local coordinate system, and we generate our ground control point file with the local coordinates. In this case, we don't need GNSS instruments or GPS instruments, which can be quite expensive, from 5 to 10,000 euros. With this approach, we eliminate these costs. More police patrols can have that kind of system, so you need then just a drone, additional knowledge how to orientate it without measuring with a GNSS device, and also works. Important is that you place those targets on a horizontal level, so you need to find area which is horizontal. Targets needs to be perpendicular, and we defined 3 meter distance between them. It's good enough for us to deliver accurate data. Nevertheless, if you have a GNSS system, or if you have a, for example, laser scanner, and you do a scan in addition, you can use all those information also to do the orientation. But today we will do with this approach. You will see this a bit later on. Okay, let's see additionally few images how we triggered the camera. As you can see, the drone is flying in a circle. The camera is always pointing in the accident area where we simulate the accident. This is already higher circle where the camera is turned a bit more nadir down, and I think here is our triple circle, the third one, which is from the lowest height. More side images, also really nice one for documenting the site. Okay, because we are pretty close to the cars, we zoom in, we can actually see all the details. There were some things thrown from the cars to see how detailed we can see them on the area, just to do a nice simulation on it. And in this way you can achieve greatest results. Okay, again, position of those cameras we can also see in a telemetry view. Here is our telemetry button, and we can see how the images were triggered, toggle text, turn off the name of the cameras, and so on. And we are already ready for first step, bundle adjustment. Click OK. This will take approximately 5 to 10 minutes for 100 images. See you in short. Okay, we are back. After 5 minutes, the bundle adjustment step was finished, and we can also already see here so-called sparse point cloud, where the cameras are matched together already. We see nicely how the drone was flying. Under it, it's so-called sparse point cloud. We can already see some terrain, a bit of car is already visible, and now we are ready for our second step, orientation with GCP targets. I will click this one, I will browse to my GCP target file. It's here, and we can see point 1, it's on 0, 0, 0. Point 2 is 3 meters, 0, 0. Point 3 is 0, and on epsilon axis 3 meters and 0. This is a local coordinate system, and we can always use that one for accident site, for example, to orientate the model locally. The another approach would be with the help of telemetry, which is more automatically, but to get more accurate data, this is the best approach in case you don't have a GNSS device. I will import this one. We can see the coordinates again. Click on next, and now what we need to do, we need to find one image where we can nicely see all targets really nicely. All of them are good actually, and then I need to show in a minimap point 3 is here, point 1 in a minimap is an image here, point 2 is on image here. And to speed up the process in the next step where we are detecting the targets, I will do the same on at least 2 or 3 images. So let's do it quickly. This is 3. Now I can already see the numbers, which one is where. So now we help to triangulate the positions in 3D if you do this on 2 or at least 3 images, and this speeds up the workflow in next step. So again, third time the number 2 on different image, and when I click on my next step, those were all perfectly centered, as you can see it here. So double mouse click to turn them off. Looks like the car is over the target, and that's why it's not visible. You can also use multiple selection like shift and mouse and deactivate the targets. And what we can see here is actually ground control point 1 is on, let's say, 50 images. Most and all. Ground control point 2 the same on at least 15 images, and so on. And in this way we orientate all images really accurately. I'm satisfied with this one. I click on next, and I should get my orientation summary about the accuracy. Because we have just 3 points, this will be perfectly accurate orientation. Let's wait for result. Okay, here we can see orientation summary in 3D less than around 1-2 centimeters, as we were waiting for. We are satisfied with the results. Click on finish, and now you can immediately see that our model is orientated based on those 3 ground control points. Next step on the lower right side is reconstruction. To get the best results, best time performance results, I will select you to set reconstruction level to high. You can go even to extreme if you have more time, but high is already good enough. I will use my graphic card on my computer and start with reconstruction. After the reconstruction, we should get a nice dense point cloud where most of the details should be visible, and let's get back in a couple of minutes. Okay, we are back, and here we can already see 3D reconstructed point cloud, a bit less than 10 million of points. We described our accident site. Even if we just focus on our small area of interest, we get wider area. This offers us good spatial presentations, why the accident happens, and includes all the object which needs to be additionally measured. Here are already visible small details, small object. This is, for example, first aid kit. This is a child seat in a point cloud, and of course cars with everything. I'm using the point render size to smaller or bigger the points. We have some noise, of course, on the windows glass, or maybe where the color is fully white or fully black. This is because of the bad texture, but definitely we have a good presentation what was happening on a field, and everything is in 3D. We can go right now already and extract the vector data from this crime scene or accident site, or we can go even next step and create a mesh, full 3D mesh. I will use the full resolution from the images. 2 million triangles will be enough. Calculation level high, good enough, and click on calculate. And additionally 10 to 50 minutes, and based on the point cloud we should get a textured realistic full 3D model. See you in a couple of minutes. We are back, and the textured 3D model is available here because we have a good data acquisition with nice 3 circles, a lot of side images, down images. We were pretty close. We can even read out the plate number easily, or model of a car. All objects are nicely visible. If you need to do and measure something like this, you can do really quickly. Here, let's say I need a 2 distance from this seat to the car. It's 0.91 meter, or maybe to locate the car for later on to measure from some kind of manholes, or I don't know, from any natural point. It's not hard to do it. Again, another dimension. So anything can be measured in a 2D. You can measure slope, 3D distance, and delta height, anything like that. Okay, so this is just one tool. It's a measuring tool. More tools we will see later on in a real presentation of the webinar. And this was the basic workflow from images to realistic 3D models. Okay, this was a short presentation from the complete workflow from images to 3D models with basic functionalities which are integrated in the 3D survey software. Probably you see how powerful this tool is. What can you do simply just out from 2D images? It's really fascinating, definitely. During the presentation, one questions pop up, and this is: Marko, will you have access both to the webinar but also to the presentation video as trial flight you did for the demo purposes? I think yes, the complete webinar is recorded, so also those videos from the 3D survey pilot and from the workflow will be generated in addition, packed in a complete webinar recording, so not a problem. And in case you will need something in addition, feel free to contact us on our support email. Okay, great. Let's continue now with the webinar, and now I will just open a 3D survey. Just a second to minimize it. So with our video presentation, we stop with the textured 3D models. I would just like to repeat the workflow, the complete workflow again. So we start with images. We did a nice 3 circle grids to get the best possible results out of it. We continue with the point cloud. It's right here. All the functions from point cloud are available here. And then we finish with the textured 3D models. Next step, which is available here, is a true orthophoto. You can see it right here. It was not presented how to generate it. I will just quickly show you here. So orthophoto, calculate new top down, and here you just define the resolution. For this case, I would take 2 millimeters, so 0.2 centimeters, because we have a really good resolution, and then you can easily read out all important data from 3D model and generate accurate 2D orthophoto. Here is also option to generate a side orthophoto. So in case you would need to generate something like that and put it in 2D, you would use this custom plate orthophoto and actually define your side plate in this way. For example, okay, I'm using the right mouse button to extend the planes under it like so, and in this way export a side orthophoto. Feel free to try it out by yourself. It's super easy, works really nice. And then in addition, we have here some CAD drawings. The easiest way to draw CAD lines, if you need to extract actually out the vector data, is to draw on mesh. That's why you can go to point cloud tab, turn off the point cloud, that you will have just mesh in a CAD tab, okay? Because in a CAD tab, you actually see everything what's turned on in other tabs, okay? And right now I have just a simple texture 3D mesh, and if I like to measure something, here is my layer system. I can add new layers, anything like that. I can select my colors, made layer active, set the thickness of line, and for example, if I would like to measure here the 3D distance like I did in the presentation, I can actually easily snap here and up to here, let's say from the seat, and see this is a 3D distance 1.29 meters. Okay, so it's super accurately, and in this case we can get any informations out of it. Maybe just for your info, extracting those informations takes quite a bit experience. Also, for example, if I extract road in my case, I will go here where I have the draw line tool. I would like to display the 2D distance on it. Then you need to zoom in with the left mouse click and click where you would like to set your break line point, and in this way creating a border between road and grass, for example. Now I'm connecting this in a 3D and it's already finished. I was surprised when I asked our federal police agency how they are doing this. They explained me that they actually don't do any additional vectorization, but they just deliver them a 3D model from 3D survey to court. They have option to use our free 3D survey viewer, which is free available from our web page, and they inspect from the 3D models in a real time, then based on textured 3D models. And then in addition, if there's something they need to draw out of it, like a 2D map, vector map, or something like that, they do it later. But if they don't need it, the 3D model is good enough, accurate enough, and offers definitely the best presentation. Okay, cool. Another interesting feature, here you can see I marked this point, the gas tank, with my point 1. So you can use our point. Let's change the layer to objects, like creating a new point. And if you write in a point code, let's say any name like first at kit, you can actually add some comments to your 3D objects. Okay, I generate point with coordinates and short description. Okay, in this way you can do for any object which was in the crime scene or accident site, and name it or anything like that. Okay, so here you can find most of the tools to generate some kind of quick sketch and later on project them on an orthophoto. You have actually measuring option, you have new point option, you have a draw line option, you have a circle, draw circle tool. So if you would like to generate some kind of areas of interest or anything like that, and always when you are drawing, you're actually drawing in 3D. Then when you move between the tabs, those data are always visible. If you go to mesh tab, you see it also here. Then in addition, we have bounding box here option. If you would like to inspect something really detailed, use the right mouse click on the plane, smaller it like that, turn off the bounding box, and you simply see what you like to see. Okay, you can even move those planes fully together like so, and use the Control and right mouse click and slide between this model and see if those cars are actually in collision or not. In our case, we simulate the accident, so they're actually not. But if there's an accident, you will definitely see. Reset view brings you to the everything back, and that's it. Then what's another useful thing is if you go here to orthophoto, you see all those elements on orthophoto. Maybe the scale of the text is too big right now. Let me go back to cat and smaller text size. The minimum is 6, I think. The minimum size. Also, this one was actually on 12. Okay. And now if we go to orthophoto, this is a much better representation from our sketch. We have a true orthophoto with all the elements on it. We have some notes on it. The road was drawn out, some road maps is marked here, and I can export this as a quick sketch. With a scroller on the mouse, I can zoom in. The scale is immediately changing. I can set to landscape if I like. I can move and position my model, and accident site could be on, profiles off, control lines off, volumes off. So I would like to have scale and cat data, and then just browse it to your file and save it as a quick sketch. Okay, so traditionally they've been doing this quick sketch with a pencil and paper. Now we have a sophisticated tool for doing that kind of measurements and exporting them or print them out or share them in 3D. Okay, then last thing I would like to show you here is actually our recorder function with which you can do fully realistic fly-throughs based on your 3D models, and it is super easy to use. Just click on recording, and then the video recorder pops up. It asks you to set the first camera position and click on add. Move the model a bit, add another camera. Let's go a bit further, add. Now we would like to go a bit closer, and now I'm actually adding camera position to generate a video presentation. So move it like here, add another one, and out. And you can see probably here my camera positions, the white line is showing how the camera will fly. The total duration should be, let's say, 20 minutes. And I can go in a preview mode and immediately see how fast it is. I see the speed is okay, the perspective is fine. Let's stop the preview and start recording mode. So yes, this is okay. Confirm, and right now we are recording this. We really do our best for these functions. That's why it's so fast. It can render the video duration of 20 seconds in less than 1 minute, and you get out of MPEG-4 file format, the most standard one. You can easily share this format via email or any other platform. And actually, based on our feedback from the government police, they use those videos for brighter presentations, spatial presentation. So immediately, the one who see this video have a good presentation, what was happening on the field, what kind of object was there. So here you can see the rolling of the video in real time. And I just did it in less than 1 or 2 minutes. If you like to slower the flight, just extend the video duration. You're not limited with the camera positions or anything like that. So it's a super easy and effective way. You can even save those paths, create a new one, rename the first one first test, then another one, go to cameras, add another view, and all those are also saved in the position. Okay, cool. This was everything for today. I would like to share with you. Let me just quickly see if we have any more questions or anything like that. No is definitely the right time to set your questions. Otherwise, feel free to contact us also via webpage, or sorry, via email, support email. Check our webpage, find interesting informations on it, and definitely don't forget to try our free trial, which is available free for you. Just click on free trial, download the version, test it out, see how powerful it is, and feel free to visit all other webinars we are sharing with you. Thank you for today. My name is Marco, 3D Survey Team. Wish you a great day. Bye.